Hi, this is section 4.2 for discrete math. We want to look at what we did in 4.1, creating these graphs, and then also try to interpret what the graphs mean. And so we're going to look at what we call the earliest start time, and then also the critical path. Which one is the most important that we need to worry about if we want to help minimize our overall effect over the course of time? If you remember this example from 4.1, what happens in this example is that both me and my brother have to clean my garage. After we're done, we can go to the game. I put things away and my brother sweeps. If it takes me 20 minutes and then my brother 1 hour, what is the shortest amount of time before we can go to the game? Well, what we say then is that the earliest start time would be this longest amount. And so it's kind of a weird dynamic in that we're talking about the earliest start time is actually the longest path. And that's what we're going to look at when we look at these graphs. And so if we look at this example that we had before, what we want to do is label each vertex, first of all, with its earliest start time. What is the soonest that we can start it? Now, for some of these, it's pretty obvious, but then when we get to D, we have to look at what would be the earliest start time. And remember, this earliest start time is actually the longest path. And so that's what we want to look at. Everything else is dependent upon the longest path. I'm dependent upon my brother finishing his job in the garage. Okay, so now if I look at this, I can label each one of these as earliest start time. So this A, the earliest start time is 0. This C, the earliest start time is 0. I can start them straight away. Now if I look at B, the earliest I can start this, A has to be completed. And so we have the prerequisite of A before we can do B. So we can start B at time 2. Now if I look at the situation for D, there's two situations coming in there. One I have 2 and 4, which makes 6. And the other one is 0 and 5, which makes 5. What is the earliest start time for this? Well, since I do have to complete A and B, I have to wait until those are done to do D. This earliest start time is actually 6. Not 5, but 6. I have to wait on the longest people in order for me to start. And so that's what's happening there. Now, if you look at E down here, I can start that at time 5. Now F. If I have these labeled out, I can just subsequently add on. 6 plus 3 is 9. 5 plus 2 is 7. The earliest start time is the longest path, so that's actually going to be time 9 before I can start. And then if I finish out with this F, that is my completion time is 15. Now what I need to do then is mark the critical path. And so this is the earliest time I can finish, which is actually the longest path. Seems not the right, but that is what we do. So what we do is we go and label this. This is the longest path that we have to do. This 6 came from this path. And then we go from here. That would be the critical path. Now, if you're a management person, what you would want to do is, how can you make this path more efficient? Or if I have people waiting around from this path, can I employ them on this path? Say we're manufacturing something. Can I take them off manufacturing these pieces so that I can put them on these pieces to speed this up? And I need to make a more efficient system because maybe I need to get this down. Or we keep it like this most often, but we need a special order in quick time. Now I got to figure this out and manage this. And so that's the crux of 4.2. What is the critical path and what is the earliest start time? I hope you enjoy this assignment. We'll do 1 through 5 and then 7 and 8. Those will be the problems in the book. Have a great day.